So we're going to look at a goodness of fit test for chi-squared, which is example 12.6. So we go here to view, probability calculator, go to statistics, and goodness of fit test. So if you look at the example I've got there, there are 2, 4, 5 rows of data we need to fill in. So I just go through the observed column. That's 10, that's 18, that's 28, that's 18, and that's 12. And then the expected 13.7. You could actually use GeoGebra as well to go and find these expected values, because these are all just the outputs of a normal distribution. So 18.1, 22.4, 18.1, and 13.7. So they're the results we get. The p-value is probably the most important thing. It's 0.6248, and for this question it says that the significance level is 5%, which is 0.05. So because this is greater, in fact it's greater by quite an amount, it means that we are going to accept H0. It doesn't lie in the critical region. So that's all well and good. What we might want to do though is have a good visual representation of what's going on. So we come across here to this section. So we're going to use all the windows and aspects of GeoGebra for this. So we select chi-squared, and the degrees of freedom for this question, because we had 5 entries in the table, and you take off 1 because it is a normal distribution, that's going to come down to 4. So that's what it looks like, and we can just basically go and export that into the graphics view. So I'm going to do that. Very simple. So here we have it, and what we need to do is to take into account that the significance level is 5%. So we want to know the mark along here where it's you've got 5% to the right, 95% before it. So there's a very simple command which is inverse and chi-squared. So the degrees of freedom for this one is 4, as we saw before, and the probability to the left is going to be it's 5%, so it's going to be 0.95. So I hit enter, and you get 9.49, which is what agrees with what we would have had previously. So 9.49 is the mark along here at which the critical region starts. So let's go and make a point from that. So let's say we'll call it the big point C. C is going to be a point on the line which has an x coordinate of b, y coordinate of 0. So let's just get this out of the way. Whoops. So it's not confusing things, won't worry about that. So there's my point C. So it's 1% to the right hand side of that. So we can verify that by just putting in integral and choosing one of these options that's relevant. So it's this one here. The function is just called f. So f, the starting value is b, and it goes all the way up to infinity, and GeoGebra actually has an infinity. So hit enter, and it goes and graphs that. So that's our critical region. So then we have to look for this problem, what is the statistic that we got, and it's the value of 2.66. So let's go and create another point. So let's make it d is equal to 2.66. Sorry, 2.611. 2.611, and let's make the point on that line. So it's going to be d is equal to little d, comma 0. Alright, so that's where our value is, and that's like our test statistic. And you can see straight away that this point is not within the critical region. So therefore we actually have to accept H0. This is the region of accepting H0, that's the region for rejecting H0. So we could compare the probabilities either side.